Good morning, myself Amrita Yadav, Senior Assistant Professor, School of Pharmacy, BP202. Today I am going to discuss about Cannizzaro's reaction. Starting with introduction, the Cannizzaro reaction is named after his discoverer, Stanislaw Cannizzaro. Is a chemical reaction which involves the base-induced disproportionation of two molecules of a non-enolizable aldehyde to give a primary alcohol and a carboxylic acid. Cannizzaro first accomplished this transformation in 1853 when he obtained benzyl alcohol and potassium benzoate from the treatment of benzaldehyde with potash. Potash is potassium carbonate. More typically, the reaction would be conducted with sodium hydroxide or potassium hydroxide, giving the sodium or potassium carboxylate salt of the carboxylic acid product. Here we can see that benzaldehyde is reacted in presence of KOH to give benzyl alcohol and salt of benzoic acid. The process is a redox reaction involving transfer of a hydride from one substrate molecule to the other molecule, that is, one aldehyde is oxidized to form the acid and the other molecule is reduced to form the alcohol. The reaction involves a nucleophilic acyl substitution on an aldehyde with the leaving group concurrently attacking another aldehyde is the second step. In the first step, hydroxide attacks the carbonyl group. The resulting tetrahedral intermediate then collapses, reforming the carbonyl and transferring hydride to attack another carbonyl group. In the final step of the reaction, the acid and the alcohol oxide ions form exchange a proton in the presence of a very high concentration of a base. Here we can use KOH or NaOH. The aldehyde first forms a doubly charged anion from which a hydride ion is transferred to the second molecule of aldehyde to form carboxylate and alcohol oxide ions. Subsequently, the alcohol oxide ion acquires a proton from the solvent. Coming to scope of Cannizzaro's reaction, aldehydes with an hydrogen atom have been decongesting due to strongly alkaline reactions leading to enolates and potentially aldol reactions. Because it takes two aldehydes to make one acid and one alcohol, the method only produces 50% alcohol and carboxylic acid under ideal circumstances. To prevent low yield, the cross-Cannizzaro's reaction, which combines aldehydes with a much more desirable molecule, can be carried out more frequently. The reducer in this form is formaldehyde, which is oxidized to sodium format, while alcohol is changed into another aldehyde molecule. In this case, one aldehyde can be converted to its matching product rather than losing half of a single reactant for each of these two products. The output of the precious chemical is therefore high even though the atomic economic is still poor. Now, starting with Cannizzaro reaction. In Cannizzaro reaction, the aldehyde which contains no alpha hydrogen atoms undergo a self-oxidation reduction reaction when treated with concentrated aqueous base such as KOH or NaOH, and the oxidation product is salt of carboxylic acid and the reduction product is an alcohol. It involves the base-induced disproportionation of an aldehyde lacking a hydrogen atom in the alpha position. We can see that nitrobenzaldehyde is in the presence of KOH, it forms alcohol and acid. Now coming to the mechanism of Cannizzaro reaction. In the step 1, there is a nucleophilic addition. Here we can see this is the carbonyl group and the hydrogen is attached to the carbonyl carbon atom. The electron shift towards the oxygen atom due to high electronegativity of the oxygen atom. Here it will create delta minus and here it will create delta plus. This base OH attacks the carbonyl carbon, giving this product. Now in the second step there is a hydride or proton transfer. In this the electron comes under to form double bond, and again there is an attack on the carbonyl carbon to give acid and the secondary product. In the third step there is a rapid acid base reaction forming the final product. Now examples of the Cannizzaro reaction. Here benzaldehyde in the presence of a base, it will first form tetrahedral intermediate. Now the tetrahedral intermediate in the presence of another molecule of aldehyde gives benzoic acid, which is the oxidized product, and benzyl alcohol, which is a reduced product. Another example of Cannizzaro reaction is crossed Cannizzaro reaction. Crossed Cannizzaro reaction is a reaction in which there is a different aldehyde. For example, if we are taking benzyl alcohol, the other one is the formaldehyde. That is, the nature of the two aldehydes is different, is known when the reaction is carried out. This type of reaction is known as crossed Cannizzaro reaction. Benzaldehyde plus formaldehyde in the presence of NaOH, then it will form alcohol and formic acid. Coming to the intramolecular Cannizzaro reaction, our alpha ketoaldehyde gives the product of an intramolecular disproportionation in excellent yield. That is, with the help of Cannizzaro reaction, the yield of the product can be increased. Another example of Cannizzaro reaction is traditional industrial method. Traditional industrial method involves the reaction in the presence of base and acid to form glycolic acid, and the new method is the reactant react in the presence of base and acid to form the product. Now coming to the limitations of the Cannizzaro reaction. As we have earlier said that for the Cannizzaro reaction there should be no alpha hydrogen atoms. Alpha hydrogen atoms is the atom which is directly attached to the carbon atom, alpha carbon atom. So for Cannizzaro reactions to proceed, there should be no alpha hydrogen atom. Cannizzaro's reaction is limited to aldehydes such as formaldehyde and benzaldehyde, which has no hydrogen atom on the carbon next to the functional group, that is CHO group. Only aldehydes that cannot form an enolate ion undergo the Cannizzaro's reaction. Some more applications of Cannizzaro reaction. The intramolecular Cannizzaro reaction of methylaldehyde result in orthohydroxymethyl benzoic acid. Intermolecular Cannizzaro reaction can change ketoaldehydes into hydroxycarboxylic acid. Next, in the presence of strong alkali, furfural produces feroic acid and furfuryl alcohol. The Cannizzaro reaction can be utilized to influence a non-enolizable aldehyde disproportionation. In the industry, polyols are produced utilizing a combination of the crossed Cannizzaro reaction and aldol condensation. Polyols are highly valuable and is used in a variety of industrial processes. Neopentyl glycol is a component of polyesters that is used to create plasticizers, varnish coatings, synthetic lubricants and resins for use in or on board aircraft. Neopentyl chemical make up painters. It resistant to heat, light and hydrolysis. Pentaerythritol is in high demand as a raw ingredient in the varnish industry. It goods with an increased fatty acid content. Pentaerythritol esters are utilized as oil additives, plastifying agents and emulsifiers. Trimethyl all-propane is employed as a glycerine alternative in a number of processes such as production of polyesters, polyurethanes and alkaline resins.